Hi everybody, this screencast is all about matrices. What we're going to be learning in this screencast is how to add, subtract, and multiply matrices. We're also going to take a system of equations and write a matrix equation that is equivalent to it. Make sure you have your calculator handy like I do so that you can practice some of these operations on your calculator with me and check to make sure that you're doing them correctly. Okay, let's get started. So the first thing we want to do is talk about matrix addition. So we have these two matrices, and I want to remind you of how you talk about the size of the matrix. So matrix A is a 2 by 2 matrix, and so is matrix B. And remember that is determined by the number of rows times the number of columns. So it's 2 by 2 because it's 2 rows by 2 columns. Now for adding two matrices, if they are the same size, you're simply going to take each element that's in the same position. So imagine that you're picking up this whole entire matrix A, putting it on top of matrix B. What numbers are going to be on top of each other? Well, 3 will be on top of -1. So add those two together. 5 plus 3, 7 plus -4, and -6 plus -8. I've written it out here. I'm writing it out so that you see what's happening, but you don't necessarily have to write all that out. But when you add those together, you end up with 2, 8, 3, and -14. It's also a 2 by 2 matrix. Okay, let's look at the next example. In the next example, we're subtracting. So we have matrix A and matrix B, and we want to subtract. And just like before, instead of adding the elements that are in the same position, we're going to subtract them. And when you subtract, you'll end up with 4, 2, 11, and 2. Now you can do this on your calculator as well. So we're going to press second matrix, and we're going to edit matrix A. We'll make it a 2 by 2, and we'll put in these elements, which are 3, 5, 7, and -6. And then we'll edit matrix B. So I'll quit out of the matrix A matrix and edit matrix B, and we'll make that forgot to hit edit, sorry, second matrix, and we'll edit matrix B, and this should also be a 2 by 2. And it should be -1, 3, -4, and -8. Okay, now once you have those two matrices in there, remember we were being asked to subtract these. So we'll call up matrix A, second matrix A, then subtract second matrix B. Now it's up to you whether you want to do it on your calculator or do it by hand. Notice both ways we got the same answer. I like to do adding and subtracting and even multiplying by hand, unless the systems are really big. I think I can do it much quicker in my head than I can do it on the calculator, but it's totally up to you. Okay, now the next thing we want to do is add matrices that are different sizes. So for example, we have A, B, and C here. And if I want you to do this addition, there are 3 problems. Find A plus B, A plus C, and B plus C. 2 of these you cannot perform. So let's look at them one at a time. If we want to do A plus B, matrix A is a 2 by 3. Matrix B is a 3 by 3. If I put matrix A on top of matrix B, like I described in the previous screencast, there's nothing on top of this row. You cannot add or subtract matrices if they're not the same size. You can only add or subtract them if they are the same size. So you can only do A plus C or the reverse of that, C plus A. But you can't find A plus B and you can't find B plus C. See, look. Matrix A is 2 by 3. Matrix B is 3 by 3. Matrix C is a 2 by 3. You can only add A and C because they're the same size. So A plus B is not defined and B plus C is not defined. And I know you know how to do A plus C by now. So add those elements that are in the same position. 1 plus 10, 0 plus -1, 4 plus -3, etc. Or you could do it on your calculator. Okay, let's turn our attention to multiplication now. Now, in multiplication, there's two types of multiplication. The first example is one like this, where I want you to find 3 times a. This is called scalar multiplication. And you simply are going to take every element of a and multiply it by 3. So you get 3, 0, 12, 9, -6, and -3. Okay, that's how you do scalar multiplication. Now, what I also want to show you on this screen is a problem where you're going to combine those two operations that you've learned. So you're going to take 2 times a and subtract c. You could do this easily in your head, multiplying 2 times a and subtracting c. So that would be like 2 times 1 minus 10. And you're going to do that for every element. Like I said before, I wouldn't write all this out, but I would do it in my head and I would get the answer -8, 1, 11, 4, -19, and -2. But let me show you how you would do that on your calculator as well. So we have to edit our matrices. So we're going to edit matrix A, which is a 2 by 3. And the elements are 1, 0, and 4. And then 3, -2, and -1. And do the same thing with matrix C. And matrix C, I think I already plugged that one in, but we'll look at it. And so matrix C, yes, is 10, -1, -3, 2, 15, and 0. Now, if I want to do this equation, 2 times a minus c, so I can type 2, call up matrix A, minus, call up matrix C, and enter, and you'll see we get the same answer. Okay, now what about the other type of multiplication? The other type of multiplication looks like this. We want to find a times b, we want to find a times c. Now, what are the sizes of the matrices? Matrix A is 2 by 3, matrix B is 3 by 3, and matrix C is also a 2 by 3. To do the matrix multiplication, you have to pay attention to the size of the matrices. So for example, A is 2 by 3, B is 3 by 3. You want to look at these inner dimensions. That's the columns of the first matrix and the rows of the second matrix. Same thing here. A is a 2 by 3, C is a 2 by 3. Look at those inner dimensions. Here they match, and because they match here, we can actually do that multiplication because the number of columns matches the number of rows. But let's look on this side. Here they don't match. The number of columns doesn't match the number of rows. When these inner dimensions do not match, then this multiplication is not defined. We can't do it. Okay, so the only multiplication that we can do is a times b. So we know we have a 2 by 3 that's multiplying a 3 by 3, right? The product is going to be a 2 by 3. Let me show you how I know that. So once you know that the inner dimensions match, look at the outer dimensions. The number of rows by the number of columns is what your answer is going to look like. Now this process is a lot harder to explain in words than it is to just show you how to do it. But let's go through this. We're taking matrix A and multiplying by matrix B. So what you're going to do is you're going to take this row, which is this 1, 0, 4. I tried to color code it for you. And you're going to multiply that row by this column. So think about picking up that row, rotating it, putting it on top of 1, 0, and -7. So the 1 will be on top of 1, the 0 on top of 0, and the 4 on top of -7. Multiply those numbers that are on top of each other, and then add that together. I wrote it here. So it's going to be 1 times 1 plus 0 times 0 plus 4 times -7, which ends up being -27. Now, remember I said the answer is a 2 by 3. So we have 5 more elements that we have to figure out. We figured out this one was -27. Now, to do this, you're going to have to do this row times every one of these columns. That's going to give you the first row of your answer. Then you're going to take the second row and multiply it by the first column, second column, and third column. So you're going to take, for example, 3 times 1, -2 times 0, -1 times -7. So that would be 3 plus 0 plus 7, which is 10. And you'll see on the next screen, that's the answer. So you add those together. Does that make sense? 1 times 1, 0 times 0, 4 times -7, that's -28 plus 1. That's where we got -27. And you do that for every row by every column. Now you can do that on your calculator too. So you can put these in your calculator. So I think second matrix A has the correct matrix in it. Let's just check. And it does 1, 0, 4, 3, -2, -1. But I am going to have to edit matrix B. So matrix B is supposed to be a 3 by 3. Okay, so now I've edited matrix B. So to do this multiplication, second matrix, we're going to call up matrix A, and we're going to multiply, whoops, press the wrong symbol. We're going to multiply it by matrix B. You don't actually have to put the multiplication sign between them, but you can or you cannot, it doesn't matter. But you'll notice when we multiply, we get the same answer. Okay, one thing I want to show you is what happens if you can't do the multiplication. So for example, if I try to multiply matrix A by matrix B, that I meant by matrix C, A times C, that multiplication is not defined. And you can see you get this dimension mismatch error message. And that's telling you dimension mismatch. It's not that you typed something wrong, like a syntax error, but that there's something wrong with what you wanted to do. Okay. The next thing we want to do is talk about the last learning outcome, which was to take this system of equations and write a matrix equation that's equivalent to it. So what we're going to do is we're going to separate this into a coefficient matrix, the variable matrix, and the constant matrix. So our variable matrix we're going to call A. Our coefficient matrix we're going to call A. So that's all the coefficients, 4, 2, negative, whoops, I should have had a -1 there. Okay, let me do that again. So whenever we write the coefficient matrix, which was 4, 2, -1, and the coefficient 9, notice there's no y term, so the coefficient there is 0, and then 1, and 4, 5, and -2. There we go. And then we're going to call x our variable matrix. So this is the coefficient matrix, this is the variable matrix, and then we have our constant matrix. Now that we understand the multiplication, remember if we're going to multiply, we can do matrix A times matrix X because the number of columns here matches the number of rows. And in fact, if we do A times X, we end up with the left side of this equation. So that means we can write this equation as A times X, and that's going to be equal to B. So if you multiply each row by each column, you'll end up with 4x, 2y, -z, 9x, 0y, z, and 4x, 5y, negative 2z. And that will be equal to this 3 by 1 matrix, 3, 5, and 1. Okay, that's all you have to do in this section. So good luck. Email me with your questions.